Hello. In iOS 17, Google made two major announcements for Android app developers. First one was of course Kotlin and second one was architecture components. In fact, architecture components didn't get much buzz because by the time it was announced, most of the developers had left to learn Kotlin. Let's first address the elephant in the room. And the elephant is lifecycle, the unique and challenging feature of the Android framework. On desktop, a user clicks an app, opens it, works on it, and closes it. That is the lifecycle. But on Android, an activity, which is a representation of an app, might get created multiple times during a single user experience. Let's see what kind of challenges this brings to us. Memory leak. There is an object which holds a reference of an activity, and for some reason that activity gets recreated. So the older instance gets destroyed, but it can't be garbage collected because the reference of that activity is being held by another object. This leads to memory leak. In fact, this is such an issue that beginners at early stage need to learn how to avoid them. Async tasks these days are mostly used to teach us how memory leak happens. Data persistence. Suppose in your activity in onCreate method you are fetching some data, and for some reason activity gets recreated. Maybe user changed the orientation. The onCreate is called again and the data is fetched again, which was not required. User didn't ask for it. So this leads to inefficiency. What has Google offered? Google wants to be more opinionated how apps should be developed and more guidance to the developers. It's not providing a solution but a tool in the form of architecture components using which we can create better apps. Architecture components. There are two sections. One is lifecycle related, which contains classes like lifecycle owner, lifecycle observer, and then there are components related to data persistence like live data, view model, room. Let us discuss them briefly one by one. What is lifecycle owner? Lifecycle owner is an interface, and any class which implements it becomes a lifecycle owner. Currently, Google provides us two classes, lifecycle activity and lifecycle fragment, which are lifecycle owner. The important thing is lifecycle owner contains a lifecycle object which sends notification about lifecycle events to its observer, lifecycle observer. This is an interface and implemented by those classes which want to receive lifecycle events. And those events are received through annotations. Let us discuss lifecycle classes in slightly more detail. Lifecycle is an abstract class. It has two enum and few methods. Enum state has values initialized, created, started, etc. This is something new. We used to get only events, which was for a moment, but now there are states which we can inquire and find in which state a lifecycle is. Event enum has values onCreate, onStart, etc., which we usually get in our activity or fragment. And then there are methods to manage observers. Lifecycle registry class, it extends lifecycle class. It manages observers and pass on lifecycle events to those observers. Lifecycle owner is an interface. It has only one method, getLifecycle, and it returns a lifecycle object. Lifecycle registry owner, it extends lifecycle owner interface, and it overrides getLifecycle method and returns lifecycle registry object. And then finally comes the lifecycle activity, which we are going to use as a lifecycle owner. It implements lifecycle registry owner. It overrides the method getLifecycle and returns an object mRegistry of class lifecycle registry. Let us see how lifecycle observer and lifecycle owner works. My lifecycle observer implements lifecycle observer interface. Lifecycle observer interface doesn't contain any method. It's just there to mark this class as a lifecycle observer. In its constructor, we are passing lifecycle owner object, and then we are calling getLifecycle method, which returns a lifecycle object, and then we call addObserver method of lifecycle object and pass the instance of this lifecycle observer class. Lifecycle events are received through annotations. As you saw, no miracles happened. We already get lifecycle events in our activity and fragment. Now we can get in lifecycle observer classes, not a big deal. But then it provides a better separation. Our activity and fragments on start, on stop, these methods won't be cluttered. This separation from architecture point of view is a good move and it will lead to a clean code. Now let us discuss data components. Live data is a class with generic type. It's a wrapper to a data which can be observed. It's a lifecycle aware, which means it gets lifecycle events. Here's an example. We create an observer object, myObserver, then we call live data's observe method and we pass the lifecycle owner object as well as myObserver object. Now this lifecycle owner object which we have passed, live data uses it to observe lifecycle events. That's how it knows when to send us data and when not to. The best thing about ViewModel class is it survives configuration change. The way we get an object of ViewModel class in our fragment or activity is we call ViewModel providers off method and then pass the instance of fragment or activity. Then we call get method and then ViewModel.class. ViewModel is a perfect container for live data as it persists configuration change. So it solves our issue of fetching the same data again and again. Sharing data between fragments of an activity is easy. In fragment, instead of passing the instance of the fragment in off method, we pass the instance of activity using getActivity. So it returns the ViewModel object of activity. Don't put any references of activity or fragment to avoid memory leak. ViewModel persists configuration change, so it doesn't match the life cycle of activity or fragment. Room is an object mapping library for SQLite. Those of us who fetch cursor from SQLite know that we have to iterate through the cursor, extract the data, put them in POJOs, maybe create a list of POJOs. The good thing is all this is done by Room automatically. Room has less boilerplate code as compared to what we use for SQLite. Room is intelligent also. So with these two lines of query, we are getting a list of users matching a name with a particular keyword. Room also checks error at compile time, so this should help us find out bugs. Observability. Room can also return live data, and this is how all these components connect. So we have lifecycle activity, lifecycle fragment, which contains ViewModel, which contains live data returned by Room. And then Room also supports RxJava 2. Here is the overview of architecture components. We have activity fragment, which observes live data held inside ViewModel. ViewModel fetches it from repository, and repository fetches either it from Room or remote data source. Here repository is an abstraction layer. We could have directly called Room from ViewModel, but using this abstraction layer repository, we are being flexible with the data sources. Roadmap. Architecture library is in alpha version right now. Hopefully soon we can get a stable version. It requires Android Studio version 2.3 or higher. Currently there are two new classes introduced, lifecycle activity and lifecycle fragment, which are lifecycle owner. Later these classes will be merged respectively with AppCompat activity and fragment, so we can use them normally as we do now. What next? Google has picked up popular practices and tried to implement them in Android framework. This shall reduce the learning curve and hopefully motivate more developers to use them. I would say again, these are not solutions to a problem, but tools to improve our apps. I would suggest to go ahead and read the architecture guide, read the documentation, try out the code labs. I have put few links in the description box. You might find them useful. Thank you.